Hello, welcome. Waka Waka breaking it down. Sorry, no breakdance video today. We're going to go pretty quick through this one. This is the roundtable activity. I think it's class 40-ish, depending on when you're looking at this. But the whole idea today is solving intersections of graphs or intersections of equations. We want to be able to do it algebraically mostly, and we're still going to be practicing with the square root function and the quadratic function and inverse functions. Still going to be working with all that. But you're going to notice that on all four of these questions, they have a part D to them. And the part D has you equaling something that you're going to have to solve. And they get harder as we go along. So that's the main goal in all this is part D. The rest of this stuff should be review. So I'm going to go quickly through those and spend more time on part D on each of these questions. Okay, the first one, they give you the equation of a quadratic. It's kind of like, the projectile motion problems that we've done in the past. So you have a negative kind of gravity. They're using 5 instead of 4.9 or whatever, just simplifying things a little bit. But you're going to notice they say x is greater than 0. Well, that makes sense because that's the time that you drop the pumpkin from a 3-story building, right? So they say explain the meaning of h of 0. So you're just taking your equation, putting 0 in for x, as you can see down here, and solving. So that whole piece goes to 0. 10 minus 0 is 10. So what's the meaning? Well, they told us that x was in time. So this is 0 seconds. So after 0 seconds, like basically at the beginning when you first drop it, the pumpkin is at a height of 10 meters. Their answer was 10. It also makes sense from the equation. You're starting with a height of 10. That's your initial height, so 10 meters. So this is nothing new. Okay, now we're doing the inverse. So now they're like, oh, let's take 0 again, but this time let's use the inverse function. So what you need to know in your brain is that, well, if I see this little -1, that's the inverse. If it's the inverse, then the number inside there is not the x value anymore, it's the y value. So we're asking ourselves, when is this equation equal to whatever value that is? So you're kind of replacing the whole h of x with 0. That's what goes in there. Okay, so you can see that here. Whole equation equals 0. Using PEMDAS, you work backwards, right? Just subtract 10 from both sides, divide by -5 on both sides, and then you get down to this square. And that's kind of the whole point is when you're working with squares and square roots, it gets a little tricky. So let's take a look. You take the square root of both sides. Now, technically speaking, you're going to get a plus and a minus, right? We only leave the positive here in the answer key because you wouldn't really want to talk about like a negative time, right? Like it wouldn't make sense to go backwards in time. So we just ignore the negative piece and use the positive one because it makes sense, right? So there's only one solution. Also, you can see up here, they told us that our time had to be greater than or equal to 0. That's part of the domain restriction. But it also makes sense, right? Okay, so they say it in words, when the height of the pumpkin is at 0 meters, it has been 1.41 seconds. So that's basically when it hits the ground, right? It took 1.41 seconds to get there. Okay, now we're saying let's actually find the equation of the inverse. So you should know by now, you switch the x and the y's, right? You can see that there. And then we solve for y. So same process, subtract 10, divide by -5, and then you take the square root of both sides. Again, technically speaking, there's a plus and a minus here. We're going to leave the minus part off because we know that we have that domain restriction at the top. So when you do the inverse, it's also going to apply to the inverse. Graphically, you're going to have this to start off with as your graph. And you're only taking this right-hand piece of it, and you're ignoring the left, right? This is going away. So when you do the inverse of this, this is kind of where it is on the graph. When you do the inverse of that, it's going to end up going this way and look like that, right? I don't know if you can catch that, but it's this positive 10 is going to come over here to this positive 10. And then this is like, what is it, 1.41 is going to go up here to 1.41. And it's going to, like, your x's and y's are going to switch, right? So it's going to look like that is going to be your inverse. Right, you can see the equation would only make sense for the positive values of that, right? We wouldn't want to have anything, down here, like the y values in a negative, right? We only want the positive y values, right? So hopefully that kind of all comes together. Now here they go. So this is the hard part. So using part C, what your inverse, they say let's make the inverse equal to 1. So I take the inverse that we found, this inverse, which you can see here, and set it equal to 1, just like they told me. There's no deeper meaning yet. It's just practicing solving equations. Okay, so let's solve. How do you get rid of a square root? Well, you square it. That's the opposite of square root. So you square both sides. 1 squared is just 1. The square root goes away over here. So that's a little nicer to work with now. Multiply both sides by -5, right? And that's what you get down here. And then add 10, and you get a +5. So if I go back to that graph of the inverse, remember the inverse was kind of like this, kind of, sort of. And we said it's equal to 1. So we took the line 1. This is just 1. Y equals 1, right? So it's like just a flat line like this at 1. And what we're looking for is this intersection. We're saying what x value shows me where that intersection is. Okay, so that would be 5. So at a time of 5, this was 10, remember? So at a time of 5, the height would be right at 1. Whoops, I'm a little off there. Right, that's kind of the idea. So on a graph, it's just looking for the intersection between two equations. Algebraically, you need to be able to solve these and show us how it's done algebraically. So you need to be able to do both graphs and equations. Contextual wise, remember this was the inverse. So the 1 is in seconds because that was the inverse is equal to it. So that's seconds. And then the height is what you solved for, 5 meters. So after 1 second, the height was at 5 meters. Okay, that's the part you really need to focus on, solving algebraically. Okay, so quickly, I'm going to go real quick through this first part now. They give you this red part and this line, right? And they say, write the function for f of x. That's the red one. So remember, this is just a square root function, which they have. The original square root function looks like this. So you can see how we took the same thing and we just shifted it to the left 2 and down 3. So you can see we have a +2 to make to represent shifting left 2, and then -3 to shift down 3. Okay, and then we graph this. That's the blue line you see there. Everybody should know how to graph a straight line. Y-intercept -3, slope is 1. Okay, so you got a graph. We're looking for this intersection. I can see it on the graph. I can see what the solution is going to be, but we need to be able to do that algebraically. So on the graph, I can see what the answer is already, but let's find out what happens when you do it with the graph. Okay, so I take my equation that I had for the red piece, and I take the line, and I set them equal to each other. How do I solve this? Well, for me, the easy way would just be to add 3 first. I mean, that's pretty much what you need to do. There's no other way, really. That's the best way to do it. Add 3 to both sides. So these actually cancel. That makes it a lot easier. When I square both sides to get rid of the square root, you get your x plus 2 left over, and then over here you have x squared. Now, we're going to start talking about extraneous solutions. This is exactly where this extra solution comes in. When I square both sides of an equation, like I did here, you're going to be introducing an extra solution. Almost always, you're going to get an extraneous solution. Okay, but it'll come out in the algebra. So subtract x, subtract 2, you get a quadratic. Usually you can factor it, but maybe you have to use quadratic formula, but usually you can factor it, and then you get 2 and -1 as possible solutions. Now I'm saying possible solutions because they're both not valid. If I look at my graph, we see that 2 was one of my solutions. That was actually a good solution. -1 would be a solution if I was using the bottom of my graph from the parabola, But I'm not. I'm just using this. I'm just using the square root, the positive square root piece. I'm not using the negative square root piece, right, from the original equation that I had. So we only want that one solution, and we're going to say -1 is an extraneous solution. That's what you need to be able to say. Okay? Right. So the rest are very, very similar. This one, you set them equal to each other down here. Well, you graph them first, right? You got to graph them, and you're going to see that these don't even overlap. So right away, I know I'm not going to have any kind of solution to it. All right. You're supposed to be talking about domain, right? The domain of this is -6 left. The domain of this is 2 to the right. So you can talk about that. And just from the graph, I can tell I'm not going to have any solution because they don't overlap. They're not equal to each other anywhere. Algebraically, what happens? Well, when you square both sides here, you're going to see things kind of simplify down to this. And it's really kind of much easier to work with. And you're going to get this solution, x equals -2. If you try it in the equation, like, oh, does -2 work, right? So if I try -2 in my two pieces, right? Try it in here separately, try it in here separately, and see what you get. If I put -2 in there, I'm going to be taking the square root of a negative number, -4, and it's going to end up imaginary. That's not really a solution. That's imaginary for us. If I put -2 into here, I'm going to get a +2 minus 6. That's -4 as well. Again, I'm going to get an imaginary number. This is not really a solution. I have a negative imaginary number and I have a positive imaginary number. Those are not equal to each other, and besides that, they're imaginary. So this -2 we solved for is actually an extraneous solution. Okay, and you just got to be prepared to check your answers. And you can always just plug them in and check to see if they work or they don't work. You can also usually look at the graph too, right? If you have it, maybe you don't have it though, and check that as well. All right, so there's two more problems. You'll see they work pretty much exactly the same way. In this case, we have like our square root graph, and we also have our linear piece to it, this x, right? They say make it equal to x. So that's what this dotted line is. And we're trying to find out where those are equal to each other. So we got to just solve things. You're always trying to move everything over to one side and get the square root piece by itself. Then you can square both sides. So now I'm okay to square the right. Don't forget the negative in there. And square the left, right? And then what you're going to find is you're going to often have a quadratic like this equal to 0 if you move everything to one side. Then you can factor it, look for your solutions, but you're not done. You can't trust it. You have to check those solutions, either check on a graph to see if it makes sense, or just take those numbers, plug them back into the original graphs, or original equations, and see if they make sense. They should be equal to each other if it really is a solution. When you do that for here, you're going to find that that 4 is a solution, but 7 is extraneous. It doesn't work. It just doesn't work. So you're just going to have to practice, play around with that. Good luck. Let me know if you need help.